Hey guys, how's it going? It's me, Ralph, here today. So today, instead of doing my usual anime piano, I'm going to share a math problem with you guys. Now, I know math problems, ugh, but I came up with this one on a road trip and I thought it was interesting enough to share. And so, I'll just share it. Haters will hate, but, well, let's get to it. So, suppose we had a bag of marbles. That's a bag. And in the bag was an infinite number of marbles. Well, I shouldn't exactly say infinite number, but I want to say a very, very large number. So large we can basically call it infinite number. Infinite number of marbles. Every marble is either red or green. Now let the percentage of red marbles, if we take the number of red marbles divided by the total number of marbles, that would give us percentage of red marbles. Let's call that P. And P obviously can be anything from 0% to 100%. But we're going to say that it can be anything from 0% to 100% with equal probability. So it can be anything, and it's not more likely for it to be 30% than 50% or whatever. So suppose I reach into the bag, I take out a marble at random, and it's red. So I reach into the bag with infinitely many marbles, with each marble being red or green. I take out a marble at random, and it just happens to be red. So I take out another marble, because why not? Another marble. So now the question is, what is the probability that the second marble I take out is also red? So just reviewing the problem, bag, infinite marbles, every marble is red or green. I pick out a marble at random, it happens to be red. I pick out another marble. What is the probability that that marble is red as well? So first, it's not 50% for reasons that I will discuss in the solution. So pause the video now to find the solution for yourself, and I will give the solution in 3, 2, 1. Alright. So here's the solution. Now the problem with this problem, it's a problem, of course it's got to be a problem, yeah, okay. So the problem with this problem is that you have to consider an infinite number of marbles. And yeah, we're going to ignore the fact that if it had an infinite number of marbles, the bag would turn into a black hole and make the universe collapse around it. We're going to ignore that for now. So the problem with an infinite number of marbles is just overwhelming. It's overwhelming to have to consider an infinite number of marbles. So instead of saying infinite number of marbles, we're going to say it has n marbles, and consider what happens as n approaches infinity. So let's just do that. Erase, 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 erase. N marbles. Well, if there's n marbles in the bag, then obviously the number of red marbles can be anything from 0 through n. So let's just write each of these out. 0 red marbles, 1 red, 2 red, 3 red, etc., etc. N red marbles. And since we said that the percentage could be anything with equal probability, when we make it a finite number of marbles, that basically translates to each of these possibilities is equally likely. So, remember, probability is equal to number of success trials number of successful trials over number of trials we care about. Successful trials over the number of trials we care about. So then, let's calculate the number of successful trials and the number of the number of trials that we care about, divide it to get our probability. So with 0 red marbles, what we're basically doing here is like taking out 2 marbles from the bag one at a time. Because like remember the problem, I take out 1 marble, it's red. I take out another marble, what's the probability that that one is red as well? So I'm basically taking out 2 marbles. Now with when there's 0 red marbles in the bag, the first marble I take out has to be green. So no, that's not the best way to approach it. Let's do it this way. So when we draw out 2 marbles from the bag, one at a time, there's 4 possible ways we can like draw 2 marbles from the bag. We can get red, red. We can get red, green. We can get green, red, and we can get green, green. And then let me rewrite that so that it's a little bit cleaner. So red, 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 green, green, red, green, green. So then in the case where there's 0 red marbles at the end, we're not going to get red, 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 green, or green, red. So 0, 0, 0. All of our trials are going to be green, green because there's 0 red marbles. All the marbles have to be green. So we'll just say 1 for like 100% of the trials. For 1 red, well, we can do some basic calculations. Like for this one, to get red, red, the probability of getting the first red is 1 out of n, because 1 red marble out of n marbles, so 1 out of n. The second one would also be 1 out of n, because it's also red, so like, yeah, 1 out of n times 1 out of n. This is assuming that we put the marble back after we take it out. When there's an infinite number of marbles, it doesn't matter whether we put back the first marble, because it's such a large number, it would not have a significant difference. So we're just going to say that we put back the marble because the calculations are slightly easier that way. For the next case, 1 red, 1 green, probability would be 1 over n times, to get the probability of green, you just take 1 minus the probability of red. That's equal to n minus 1 over n. For the next one, green, red, the probability would be the same as this, but the terms are reversed. And green, green is n minus 1 squared over n squared. And then we do the exact same calculations for each of these rows. I'll just write these out. So 2 over n times 2 over n, because like 2 red marbles and marbles total. So it would be 2 over n times n minus 2 over n minus 2 over n times 2 over n, n minus 2 squared over n squared. Next one, we can do the same thing, same calculation. Sorry, my handwriting's not too great. Times n minus 3 over n minus 3 over n times 3 over n. This one's n minus 3 squared over n squared. We can do the same calculations, and from this we get that when there's k red marbles, we get that the probability of red, red is k over n times k over n. Red, green is k over n times n minus k over n. Green, red, n minus k over n times k over n. Green, green is n minus k squared over n squared. So when there's n red marbles, it'll just be 1, 0, 0, 1. Alright, that's all like beautiful and stuff, but what good does it do? Well, we know like probability is successful trials over trials we care about. Since remember, I said that the first marble I pulled out is red. So all of the trials that we care about have the first marble I pull out has to be red. So that means we don't care about the trials where the first marble I pull out is green. So yeah, we erase the ones where the first one is green. So goodbye. We don't care about these anymore. So like this total, these are the trials that we care about. And the successful trials are pull a red, pull another red. So red, red, these are the successful trials. And these combined are the total trials that we care about. So then if we write that out, oh man, that looks like a nightmare. Actually, this is what we'll do. We'll actually calculate the total trials that we care about. So care about, CA for the trials that we care about. If we add these up, we get 0. This is yeah, I can totally do math. Wait. Alright, this is just 1 over n, this is 2 over n, 3 over n, k over n, etc., etc. This will be 1. So these are the trials for each color that we care about. So if we total these up, we'll get T is total success trials over total we care about. Success just means red, red, so we'll rewrite it as total red, red. And then we just add these up, we would get 1 over n squared plus 2 squared over n squared plus 3 squared over n squared plus ... plus n squared over n squared. That's total red, red, because like we just add these up. For the total that we care about, we just add these up. That would be, we'll ignore the 0. 1 over n plus 2 over n plus 3 over n plus ... plus n over n. Now this is a probability for getting a red marble after getting a red marble. So now we just simplify that. Let's multiply the top and bottom by n squared so we don't have fractions. 1 plus 2 squared plus 3 squared plus ... plus n squared over, multiply that by n, so n times 1 plus 2 plus 3 plus ... plus n. Let's see, the sum of the first n squares, shoot, I forgot. I don't want to derive it though, because then you guys will be like bored. Maybe I can show the derivation for the sum of first n squares in another video, but not today. I'm gonna go look it up. Okay. Siri, what is the sum of the first n squares?
Okay, I found this on the web for what is the sum of the first n squares.
That's not very helpful. Alright, let's try just searching it. Yeah, here it is. Okay. So the sum of the first n squares, that's equal to n times n plus 1 times 2n plus 1 over 6. Alright, so this is just the sum of the first n integers. I can also show how to simplify that, but I'm not going to. That's equal to n times n plus 1 over 2. I'll show how I got from here to here in another video, if you guys are confused about it and you want me to show it. So now we just simplify, the n cancels, the n plus 1 cancels. We can cancel the 2 here and make this a 3. This becomes 2n plus 1 over 3n. And that's a probability for n marbles. But remember, we're going to say, like, we're going to observe what happens as n gets very, very large. In other words, as it approaches infinity. So then the question becomes 2n plus 1 over 3n equals what as n gets very, very, very large? Well, 2n plus 1 over 3n is equal to 2 plus 1 over n over 3, because you just divide the top and the bottom by n. As n gets very, very large, 1 over n approximately equals 0. Since we let n equals infinity, well, let n approach infinity, this approximation becomes exact, and we get 2 plus 0 over 3, which is just 2/3 as the probability. And that's our answer. Now, as for why, like, 1/2 is not the answer, it's because, like, we have the condition that the first marble we pull out is red. And if there's more, like, And if there's more red marbles, there will be more trials that we care about. Because there's more red marbles there's going to be more trials where we pull out the red marble the first time if there's more red marbles. So that means we actually sort of favor the trials with more red marbles. Since we favor the ones where there's more red marbles, we're more likely to pull out a red marble the second time, which is why the answer is greater than 1/2. Now, if we took away the condition that the first marble I pull out is red, then the answer would be 1/2. Because, like, anything is equally likely, and the probability of pulling out a red one must be equal to the probability of pulling out a green one because symmetry. So then the answer would be 1/2. But we favor the ones where there's more red marbles because we pulled out a red marble the first time, which is why we say, well, which is why the answer is larger than 1/2. And the answer is 2/3. Alright, so thank you for watching. If you enjoyed that, please like, comment, subscribe. If there's any part of this process that you're still confused about, please leave a question in the comments below. I will answer as best I can. And of course, please leave suggestions for future videos. And yeah, thanks for watching. Like, comment, subscribe. See you guys next time.